Hello everyone, hope you all are fine. In this video, we will study about linear momentum, Newton's second law of motion and its applications. By the end of this video, you will be able to understand the use of Newton's second law in our daily life. So students, all the bodies in motion possess a physical property, momentum. Let's learn about it before starting with Newton's second law of motion. Actually students, the quantity of motion contained in a body is known as the linear momentum of the body. Let us find on what factors the momentum of a body depends. So students, consider two balls A and B. Let the ball A is heavier than the ball B. That is, the mass of ball A m1 is greater than the mass of ball B m2. Suppose both the balls are moving with the same velocity v. It is observed that the force needed to stop the heavier ball A is more than the force needed to stop the lighter ball B. This shows that the heavier ball has more quantity of motion than the lighter ball. Thus, linear momentum of a body is directly proportional to the mass of the body. Now consider a situation where two balls of same mass are moving with different velocities. It is found that the force needed to stop a fast moving ball is more than the force needed to stop a slow moving ball. This shows that the quantity of motion of a body having high velocity is more than that of a body having low velocity. Thus, linear momentum of a body is directly proportional to the velocity of the body. So students, linear momentum of a body is the product of mass m and velocity v of the body. Formula of linear momentum is mass into velocity, that is equals to P is equals to m into v. Linear momentum is a vector quantity whose direction is same as that of velocity. SI unit of linear momentum is kilogram meter per second. Students, let's learn about Newton's second law of motion. According to Newton's second law of motion, time rate of change of linear momentum is directly proportional to net force applied on the body. Suppose an object of mass m is moving along a straight line with the initial velocity u. When constant force F is applied on a body throughout the time t, then object is uniformly accelerated to velocity v. So students, initial momentum of body is Pi, that is equals to mu, and the final momentum of body is Pf, that is equals to mv. So students, change in momentum is equals to final momentum minus initial momentum. So change in momentum is equals to Pf minus Pi. Change in momentum is denoted by delta P. Now we will put the value of Pf and Pi. According to Newton's second law of motion, rate of change of momentum is directly proportional to external force. Students, rate of change of momentum is delta P upon T. So F is directly proportional to delta P upon T. This is according to Newton's second law of motion. Now we will substitute the value of delta P, that is mv minus mu. Now we will take m common from both the terms. Now this whole term v minus u upon t is equals to a. How this is possible? Students, we know that v is equals to u plus at. When u will come to the left hand side of the equation, its sign will be changed and t will come to the denominator side. This is how we have substituted v minus u upon t is equals to a. So students, F is directly proportional to ma, where a is acceleration. This directly proportional sign will be replaced by equals to by multiplying constant k, where k is constant and its value in SI system is equals to 1. If k is equals to 1, then F is equals to ma. We can say force is equals to mass into acceleration. Now we will study some applications of Newton's second law of motion. Students, we often observe that a cricket player lowers his hands while catching a ball. Do you know what is the reason behind it? We will apply Newton's second law of motion here. According to Newton's second law, F is equals to delta P upon delta T. It means force is inversely proportional to time. It means when force will increase, time will decrease, and when force will decrease, time will increase. A fast moving ball has a large momentum, and in stopping the cricket ball, the momentum of ball has to be reduced to zero. Now if player does not lower his hands while catching the ball, so the time is small and large retarding force has to be applied. Hence his hands are injured. On the other hand, when the player lowers his hand while catching the ball, the time to stop the ball is increased. Hence, less retarding force has to be applied and the hands of player are not injured. Have you noticed that in athletics, mostly high jumping athlete is provided either with a cushion or a heap of sand on the ground to fall upon? Actually students, this is to prevent injury to the athlete when he falls down after a jump. When high jumper falls on soft landing site, the jumper takes a long time to come to stop. So the rate of change of momentum is less, therefore the force exerted by the ground on athlete is also less and he doesn't get hurt. So students, in the similar manner we have applied Newton's second law of motion here. Next application is a person falling on a cemented floor gets injured, but a person falling on a heap of sand is not injured. What is the reason behind it? We will apply Newton's second law of motion here also. So students, when a person falls on a cemented floor, he comes to rest abruptly as the floor does not yield under his weight. So the change in momentum of the person takes place in a small interval of time. Hence, a large force is exerted on the person by the floor, therefore he gets injured. On the other hand, when a person falls on a heap of sand, the sand yields under the weight of the person. As a result of this, the person comes to rest in a longer period of time. So, the change in momentum of the person takes place in a longer period of time. Hence, the average force exerted on the body of the person by the heap of sand is small. Therefore, the person is not injured. We know that vehicles are fitted with shockers and shockers are like springs. The floor of vehicle is connected to the lower part of the vehicle by shockers or springs. So students, when the vehicle moves over a rough road or surface, the force due to jerks is transmitted to the floor of the vehicle. The shockers increase the time of transmission of the force of jerks to the floor of the vehicle. Hence, less average force is experienced by the passengers or goods in the vehicle. Now we will do numerical based on Newton's second law of motion. A constant force acts on an object of mass 5 kilograms for a duration of 2 seconds. It increases the object velocity from 3 meter per second to 7 meter per second. It means initial velocity u is 3 meter per second and final velocity v is equals to 7 meter per second. Find the magnitude of applied force. So we will use this formula according to Newton's second law of motion, and we will substitute the values and we'll get the result. F is equals to 10 newtons. Now if force was applied for a duration of 5 seconds, what would be the final velocity of object? Again we will use this formula and we will rearrange the terms. On simple substituting the values, we will get a result. So in this numerical velocity time graph is given. This is the velocity time graph of a ball moving along a straight line on a long table. Mass of ball is 20 grams. We will convert all the units into SI. Initial velocity is 20 centimeter per second. Velocity decreases to 0 in 10 seconds. So u is equals to 20 centimeter per second, v is equals to 0 centimeter per second, and t is equals to 10 seconds. As velocity time graph is straight line, this means ball moves with a constant acceleration. So how much force does the table exert on the ball to bring it to the rest? We know that force is equals to mass into acceleration, as mass is given but acceleration is not given. Now question is, which formula of acceleration we will use? As we have u, v, t, we can use the equation v is equals to u plus at. Substitute all the values and get acceleration. Don't forget to convert centimeters into meters. Now we will substitute the value of mass and acceleration and we will get the value of force F. A very important thing, that convert kilograms into grams if you want to have the value of force in newtons. And also there is negative sign in force, means there is a retarding force, as the frictional force exerted by the table is opposite to the direction of motion of the ball. Now one question for you students. A bus weighing 900 kilograms is at rest on the bus stand. So students, what is the linear momentum of the bus? We know that linear momentum is equals to mass into velocity. Mass is 900 but velocity is 0 as bus is at rest. So the linear momentum of the bus is 0. Thank you so much students. Hope you like this video.